Okay, we're going to go on to talk about remainders, and we have to start back in primary school when you first said what a remainder was. So then, when you had a calculation like 11 divided by 4, you said that the answer was 2, remainder 3. And you said that because you can make your 11 by doing your 4 2 times, but then you needed to add on another 3 to make it correct. So we say that this 3 here is the remainder. And we can do exactly the same thing with polynomials. Okay, this is a fact that you can check. You can multiply out this using a grid. You can take 3 away from the answer and you will get this. But if you want, you can just take my word for it. So, looks a bit more complicated, but it's got the same structure. I can make this number here, or this polynomial here, by doing this factor of x minus 2 multiplied up by this. And then to make it come out correct, it turns out I need a minus 3 at the end. So that minus 3 is what I call the remainder. So that's what a remainder is. But the good news is, firstly, I don't have to worry too much about the definition of a remainder, because we're going to concentrate on finding the value of the remainder. And the other bit of good news is that the method that I need for finding the remainder is extremely simple. So we're going to be taking a polynomial, we're going to be told what we need to divide it by, and told to find the remainder. And in this particular case, the line above is what shows me the remainder is minus 3. But now for the quick way of getting there. I'm dividing by a linear factor, okay? And once again, I have a magic x, which is the value that makes the bracket equal 0. So in this case, the magic x is 2. And as before, I'm going to substitute the magic x into the polynomial. So let's do that here. So I've replaced all of these x's by 2's. 2 cubed is 8, minus 12, plus 5 2's are 10, minus 9. And if you work that all out, you get minus 3. The remainder turns out to be the value you get when you plug the magic x into the polynomial. And I can actually explain why that's true. If we go back to this line here where we defined what the remainder was, you can see that if I take x to equal 2, that bracket here is going to be 0. So it doesn't matter what this works out to. 0 times anything is 0. So the whole of that will cancel out when I put the magic x in. And the answer I get will just be the minus 3, which is what we defined to be the remainder. So that's the way the method works. Just one more example where we see how simple it is to use this in practice. Okay, so I'm dividing by x plus 1. This time I've got a power of 4. This is called a quartic polynomial, not a cubic. I don't care. All I've got to do is say what the magic x is. So the magic x is the value that makes the bracket equal 0, which is minus 1. And then I simply plug that into the polynomial. So all the x is replaced by minus 1s in brackets. An even power of a minus is still a minus, so that's going to be 2 times 1, which is 2. Odd power of a minus is a minus times minus 5 goes back to plus 5. Plus minus 1, minus 2. So I've got 7 minus 3, it's plus 4 this time, so the remainder equals 4. And always, actually, this is so easy that make sure you don't leave any doubt, end up by saying what the remainder is. And that it really is as simple as that.